The artificial intelligence boom appears to belong to Nvidia. But behind the world's largest AI companies, another chipmaker is building a quieter path to computing power. That company is Broadcom. Broadcom does not usually sell AI processors under a famous consumer brand. Instead, it helps major technology companies develop custom accelerators built for their own workloads. These chips are often called XPUs, or application-specific integrated circuits. A general-purpose GPU must perform many tasks. A custom accelerator can be optimized for a narrower set of training or inference workloads that can improve performance, reduce power consumption, and lower operating costs at enormous scale. But designing a competitive AI accelerator requires compute architecture, memory interfaces, advanced packaging, fast connections, software, and reliable manufacturing. Broadcom supplies many of those pieces and helps customers combine them into one platform. Its advantage comes from decades of experience in custom silicon and communications technology. Broadcom's roots stretch across Bell Labs, Hewlett-Packard, Agilent, Avago, and the original Broadcom Corporation. Over time, it built expertise in Ethernet switches, optical connections, signal processing, and specialized chips. Those technologies have become essential as artificial intelligence clusters grow larger. Thousands of processors must exchange data rapidly enough to operate like one computing system. When communication slows, expensive processors sit idle, and the network becomes a bottleneck. Broadcom attacks both sides of that problem. It helps develop custom accelerators and supplies Ethernet technology connecting processors within racks and across massive AI clusters. OpenAI and Broadcom are developing a multi-generation platform of custom accelerators and Ethernet-based systems. Their announced plan targets 10 gigawatts of deployment across OpenAI facilities and partnered data centers. In June 2026, the companies unveiled Jalapeno, OpenAI's first intelligence processor for large language model inference. Meta has also expanded partnership with Broadcom to co-develop multiple generations of MTIA custom silicon. Meta says these accelerators will support ranking, recommendations, and generative AI workloads. This does not mean hyperscalers will immediately abandon Nvidia. General-purpose GPUs remain flexible and are supported by a powerful software ecosystem. Instead, major customers are building portfolios of processors. They may use Nvidia for some workloads and custom accelerators for tasks that can be optimized more efficiently. For Broadcom, that strategy is already producing enormous revenue. In its second fiscal quarter of 2026, Broadcom reported $10.8 billion in AI semiconductor revenue. That figure grew 143% from the previous year, driven by custom accelerators and AI networking. But custom silicon has risks. It is expensive to develop, depends on advanced manufacturing, and works only when customer workloads justify the investment. Broadcom must also compete with chip designers, networking suppliers, and the internal engineering teams of its largest customers. Yet its position is unusual. It does not need every AI company to replace Nvidia. It only needs the largest customers to decide that some workloads deserve chips designed specifically for them. The next challenge to Nvidia may not arrive as one famous competing brand. It may arrive as custom processors hidden inside the data centers of the world's largest technology companies. Broadcom is helping design those processors and the networks that make them useful. That is why the quiet company behind custom AI silicon is becoming the other giant of the AI boom. And that is today's Billion Gem.